The speech mechanism, or the organs of speech. We are going to learn how we produce speech sounds. This is the bibliography we've consulted. English Phonetics and Pronunciation Practice by Paul Carley. Gimson's Pronunciation of English, edited by Alan Cruttenden. And English Phonetics and Phonology, a practical course, by Peter Roach. One curious thing about the organs of speech is that none of them started out that way. They were all designed for purposes other than speech. For example, the lungs are primarily intended for breathing, the teeth and the tongue for chewing up food and passing it down to the stomach. This has led scientists to call speech as an overlaid function. Nevertheless, the human being is uniquely a speaking animal, and in the course of evolution, all the organs of speech have developed in very specialized ways, often quite remote from their original purpose. Perhaps the best example of this is the larynx. The larynx was originally merely a device for keeping chewed up food from entering the lungs, but it has evolved into one of the most intricate parts of the vocal apparatus or vocal tract, and it plays a crucial role in speech. The organs of speech fall into three groupings according to where they are located: in the head, in the throat, or in the chest. In the head, we identify the articulatory system, supraglottal cavities, that is to say, resonators for the laryngeal tone. We'll come back to this in a minute. In the throat, the phonatory system. The larynx generates most of the energy in speech sounds. And in the chest, the respiratory system. The lungs provide the air which is used in the production of speech sounds. Now, let's talk about the lungs. The respiratory system consists of the lungs and the bronchial tubes which lead to the throat. Breathing in is what we refer to an inhalation, and breathing out, exhalation. The lungs take in air and expand. When we breathe out, they contract. So when we breathe in, let's breathe in, our lungs expand. And when we breathe out, our lungs contract. This can be compared to the action of sponges. Inhalation and exhalation both take a roughly equal space of time. But during speech, the lungs take in air rapidly and let it out slowly. So speech can be seen as a type of controlled breathing. Now, you can see here the diaphragm. The diaphragm is the muscular floor of the chest. Let's talk about the speech sounds of the languages of the world. Most speech sounds of the languages of the world are produced on pulmonic egressive airstream, that is to say, while we are breathing out. But it's also possible to speak on an ingressive airstream, that is to say, while we are breathing in. This is what we do, for example, when we are sobbing or gasping for breath, when we feel out of breath after walking up the stairs. We are producing sounds while we are inhaling. Or when we produce what we call clicks or click sounds. For example, to show disapproval, sometimes we say, "That's a click sound," or when we want to make a horse move. Right? These are called click sounds. They have no phonological value and they are made on ingressive airstream while we are breathing in. So, these clicks have lots of meaning in context. They are meaningful in context, but they are not considered phonemes. Let's move on to the larynx. So we'll study the phonatory system. Phonation takes place when the airstream coming from the lungs goes up through the trachea or windpipe to the larynx. So, where is the larynx? The larynx is located at the top of the trachea. Now, the larynx is made of two large cartilages. Let's have a look at this figure. The thyroid cartilage and the cricoid cartilage. We just said that the larynx is at the top of the trachea, and you can see the tracheal rings down here. So, first of all, the air passes through the larynx at the top of the trachea. Now, what happens here? When we breathe, the air coming from the lungs passes through the trachea or windpipe and the larynx, which we said is located at the top of the trachea. Now, the front of the larynx comes to a point, and you can feel it at the front of your neck. It's a lump at the front of your throat, especially if you are a man, and it's commonly called the Adam's apple. Inside the larynx, we find the vocal folds or vocal cords. Let's have a look at the vocal cords. Let's have a look at this figure. We are looking at the vocal cords from above. This is what we call a laryngoscopic view. We can say that the vocal cords are two thick flaps of muscle, like a pair of lips. At the front, they are joined together and fixed to the inside of the thyroid cartilage. We just said that the larynx is made up of two cartilages, remember? The thyroid cartilage and the cricoid cartilage. Well, the vocal cords are fixed and joined together and fixed to the inside of the thyroid cartilage. And at the back, the vocal cords are attached to a pair of small cartilages called arytenoid cartilages. These arytenoid cartilages are attached to the top of the cricoid cartilage. These arytenoid cartilages can move, and when they move, they make the vocal cords move. Now, the opening between the vocal cords is the glottis. If the vocal cords are pressed together, as in D, the glottis is closed. If the vocal cords are wide apart, as in A, the glottis is open. These changes are very important in speech. We can recognize 4 states of the vocal cords. Now, as in A, the vocal cords are wide apart for normal breathing and during the production of voiceless consonants. That is to say, consonants which are produced with only breath. There's no vibration of the vocal cords. For example, p, t, k, f, s, th, sh, h, ch. Now, position for B. this is what we call a narrow glottis. That is to say, the glottis is neither wide apart or closed. It's narrow. This is the case of the fricative sound as in house. The glottis is narrow. And the sound is similar to that of a whispered vowel. Then, which is the position for vocal cord vibration? This is the position we can see here in figure C. When the edges of the vocal folds come into light contact, nearly touching each other, the air is pressed up from the lungs, and this air pushes the vocal cords apart so that little air escapes. They are opened and closed, and this happens very quickly, and it's repeated regularly, and this causes vibration. In other words, the air coming from the lungs goes through the vocal cords and makes them open and close very quickly. And this is what we refer to as vibration, and this produces vibration. All vowels, pure vowels and diphthongs, are voiced. They are produced with vibration of the vocal cords. And some consonants are voiced too. For example, b, d, g, v, z, j, j, m, n, o, w, y, right? How do we test this? Well, for example, let's produce b, as in boy, for example. B, b. Touch your throat. Touch the front of your throat. T, t, t. B, sorry. B, b, b. And then, when you touch it, do you feel your vocal cords vibrate? Yes, you do. Also, try saying b and cover your ears. All right, when you say b and you cover your ears, you can perceive the vibration of the vocal cords. And then position D. This is when the vocal folds are tightly closed. They are pressed together so that the air can't pass between them. This is, for example, when we are coughing. When you cough, your vocal cords are pressed together and then they open, right? Or the glottal stop. For example, some people say button and some people say button. That's the glottal stop. Well, which are the supraglottal cavities or resonators? That is to say, the resonance chambers where the air coming from the lungs is resonated. There are three resonators: the pharynx, the oral cavity or mouth, and the nasal cavity or the nose.